Hello everyone and welcome here, because we're going to see something quite incredible in terms of James Webb Telescope being able to show some captivating images of a specific type of galaxy, I must say. And this here is coming from its new infrared image of the NGC 346, and this here is known to be one of the brightest and the largest star forming galaxies or regions in the small Magellanic clouds. Now you might be wondering, what is this small Magellanic cloud all about? Or people call it the SMC. This is known as a dwarf galaxy that is located near the Milky Way, and it is classified, of course, our Milky Way is where we are residing in, and this here is known to be classified as an irregular galaxy that has a diameter of roughly around 5.78 kilopascals, and this is also around known to be 18,900 light years in terms of its diameter, which is reasonably large. And so this here is also located in the constellation of the Tucana, or which is a part of the Hadrius, which is appearing to be a fainter hazel patch resembling a detached piece of the Milky Way. So looking at this particular small Magellanic cloud and how this particular image, which is looking at this particular galaxy NGC 346, this focuses mainly on how it shows the emission of how cool the gases are and dust. And this here also includes a blue that represents the silicates and solely chemical molecules that are called the polycyclic aromatic hydrocarbons. Now these hydrocarbons, of course, are carbon and hydrogen, but most importantly they are cyclic in nature, which means that they have rings formation that are flat in nature, but these rings are known to be fused, and examples are, in terms of the simplest form, is known as the naphthalene, which has 2 aromatic rings. However, you can go broader, like 3 rings, you can go 4 rings if possible, but this type of hydrocarbons are known to be uncharged 1, non-polar 2, and most importantly they are planar. And this structural integrity of this particular type of hydrocarbon here can be found in many products on Earth. Like for example, they are known to be colorless. 1, 2, they can be found in coal, they can be found in oil deposits, and they can be produced by incomplete combustion. And this here can be either found in engines, biomass burning, in forest fires. Now the big question is this: why are we talking about this particular type of organic compound that is present in this particular galaxy? The main reason why is because of how this is known to be a starting material for abiotic synthesis, which is a type of materials that are required for the earliest form of life. So going to be interesting to see how this particular location is pretty much going to be one of those particular targets for forming life. Maybe it contains various exoplanets that has rich amount of hydrocarbons present in them, deposits specifically, and how this might foster various events that may lead to sustaining life coming from that particular form of production of this compound. So really interested to think about this in here, and also other things concerning this particular galaxy that was produced by James Webb Telescope, and various revealing results is the red emissions is from the warm dust heated by the region's brightest and the most massive stars. Next is the bright patches and filaments that marks areas with abundant numbers of protostars. And next is how research is going to be diving into how much of the pinpoint sources of light were created here, which is about 1001 pinpoint sources of light, and most of them are actually known to be young stars still embedded in their dusty cocoons. So this is going to be some incredible things that is going to be coming out from those little cocoons that will spring out many interesting star formations from these numbers that are located by researchers, and just the potential here is really rich in this particular location. Now this here, in terms of James Webb Telescope data, combines both the near infrared image and also the mid infrared camera in terms of the cameras versus the instrument, and astronomers can actually take a fuller census of the stars and protostars combined together within this dynamic region in space that is not too far away from our Milky Way. So really incredible to see how this is going to be really competitive here regarding this particular region in space that is very close to our Milky Way. How is this compared to our Milky Way in terms of the production of stars and various locations that may be of interesting look out for in terms of exoplanets, in terms of carbon content, and many more elements that may be essential for life formation in not only that region but also around that particular small magnetic clouds. And so here the results have implications of our understanding of galaxies that existed billions of years ago, and this here is known to be during the cosmic noon. Now you might wonder, what is the cosmic noon? In here it says that it is a term used to describe a period in history of the universe where galaxies underwent an era of intense star formations between 10 to 11 billion years ago. Now, during this time, nearly all galaxies in the universe were filled with star-forming nebulas. Since then, star formations in the universe has gradually dwindled. It still dazzles away in small pockets. Now, by studying star formation cluster like this particular region that we're talking about here, researchers can learn more about the era of the cosmic noon and the evolution of galaxies. So there's incredible stuff in here in terms of the result that we got from James Webb Telescope about the NGC 346 here, and how the potential here is reached not only in terms of star formations but also in terms of the content in the organic spectrum here with regards to the PAH, and also looking at how this can lead to potential for more combination of protostars and no new stars in this particular region. So I hope you found this really informative. Please hit the comment down below. Let me hear your thoughts about this. By that way, we can talk to you all soon. Stay smart as always and believe in yourselves.